Hello and welcome. We're really excited to have you here today for our OCI Multicloud office hours. This is a monthly event for EMEA. For those of you who may be new to our events, we're hosted on Cloud Customer Connect, our Oracle community forum for end users. I'll share the resource in the chat that lead you to the forum throughout the office hour today. And we'll invite you to create an account and join in the discussion. If you don't have an account, I'm Wei Han, OCI Multi-Cloud Product Marketing Manager, and today we're joined by Kishore Shetty, Senior Technical Program Manager from Microsoft, and Thomas van Beggenhout, Principal Solution Architect for Multi-Cloud at Oracle. On our panel today, we have our OCI Multi-Cloud experts, EMEA, Rahul, and Ricardo to answer your questions. The office hour format will be a short presentation followed by Q&A for a total of 30 minutes. In this session, Thomas and Kishore will first take us through the Oracle Database at Azure network topology. As a reminder, OCI Multi-Cloud office hours are a monthly virtual event. The Americas session is the second Monday of every month. The EMEA session is the third Thursday of every month. And our Asia Pacific session is the fourth Friday of every month. The event registration is posted on Oracle Cloud Customer Connect and on LinkedIn. Okay, that's enough for me. Go ahead, take it away, Thomas.
Thank you, Wayne. Thank you all for joining. Today, Kishore and I will be talking about the networking topologies, but before we talk about the topologies, there are also some specific things that you need to know for the Azure networking requirements for deploying an Exadata database service within Azure, to deploy the VM cluster within Azure. For this cluster, we need you to create a VNet, of course, and within that VNet, we need you to create a client subnet. This is what we call the client subnet, where the DBD VM cluster will create his network resources. This client subnet needs to be delegated to the Oracle database network attachments, which Kishore will touch on a little bit later. And also during the deployment, we ask you to provide a backup subnet side range. This backup subnet will not be used or will not be visible within your Azure VNet, but it will be used by the service in the backend for backup reasons. The reason why we ask you to supply this backup subnet is to avoid any overlap with any other side ranges that you might use within your network setup. When we look at the number of IPs used for this service, we need for each node, for each node of the cluster, we need 4 IP addresses plus 3 additional addresses which are reserved for the SCAN, the single client access names. On top of that, there's also the 5 reserved IP addresses within each subnet which Azure reserves. So when we take an example of a 2-node cluster, we need, of course, the 11 IP addresses reserved for the nodes and for the cluster itself. We need 8 IP addresses for the internal networking of the Oracle Database at Azure, and the additional 5 IP addresses for the Azure subnet networking. That means that a minimum client subnet needs to be a /27, which comes down to 32 IP addresses for a 2-node cluster. If you extend that to a 5-node cluster, for instance, then you would need to have a minimum of 26. Mentioned before is that we need to do the subnet delegation. But this is where I hand over to you, Kishore.
Thank you, Thomas. Hope you can hear me well.
Yes, we can.
Yeah, thank you. So I think in the first slide, Thomas mentioned about a backup service and a subnet delegation. The reason why we need to create an delegated subnet in the ODAA scenario is there is a backup subnet, which is nothing but an external service we have to inject into an ODAA network, which is created on Azure. And behind the scene, there is a backup operations happens from ODAA into Oracle OCI objects. I think this is the one fundamental reason we need to create this delegated subnet, and other maybe very not a minor way to look at other Azure standpoint of view, pure Azure standpoint of view. This is not a native services of Azure, right? This is where hardware and services comes from Oracle, and it gels on Azure ecosystem. Till then, it's a service injection. Purely, I'm from an Azure core network background that also qualifies this subnet to be delegated. Can you move on to next slide, please, Tom? Yeah. The next couple of slides I would like to run through. Having ODAA provisioned with the configuration of delegated subnet, and it resides in a VNet by default, how do you kind of an arrange or kind of an connect with the application ecosystem or other clients which necessarily using the exadata? I think most common one is creating an application within the ODAA VNet and having an the different subnet. I think the advantage of being is, I think this is the most closest proximity you can achieve, keeping your application and an exadata or ODAA on Azure close together. Anything else is like there are different hops and latencies. I think that's why I think this setup, we call it as a lowest network latency setup. I think that's the key thing I want to highlight in this slide, as well as this is a simple network topology. One VNet, there's an application subnet, and already we have exadata in a delegated subnet by design. There is no ingress or egress cost because this everything, the data movement happens within the VNet. Next slide, please. Yeah. In some cases, it is good to have a within application within the subnet, but that is not always a possible case. Already you have your applications in a different VNet, and most preferred the network topology is hub and spoke. So you can have an hub, this is a hub and spoke, and the not hub and spoke, this is more on VNet peering, assuming that the application in a different VNet and ODA in another VNet, it is simple VNet peering. This makes the communication between applications and exadata possible, and this is also a lowest network latency. This provides because this is VNet to VNet peering, not even hub and spoke, because hub and spoke adds another hop and it adds some level of latencies. But this is, I think, the second, the best latencies compared to the previous scenario we have discussed. Only we have to be mindful that to an any VNet, there is an upper threshold of 500 direct peerings. I think this is the one thing you have to keep in mind. And there is, because these networks can be, totally VNets are not single VNets like a previous scenarios. There could be the ingress and egress cost involved between the data transfer between the VNets. That is something you have to be mindful while using this peering technology. Next slide, please, Thomas. Yeah, definitely this is the one which is hub and spoke, mostly having the complex deployment scenarios. I think this is the most common network pattern. I use this hub and spoke, wherein VNet of ODAA is peer to the hub, and the other applications also peer to a hub. So applications via hub VNet, it connects to ODAA. There are a couple of things we have to be mindful about here is the local NVA requirement. It is a prerequisite for routing traffic from a delegated subnet of ODAA to hub and spoke. Why this is a requirement as of now? We have full UDR support is not yet enabled on ODA VNet. That is under, and the PG is developing, and soon we will be rolling out. Till then, I think local NVA is a requirement in an hub and spoke scenario. And there is one thing I just wanted to tell is, all the traffic control and traffic management is the UDR, the limited UDR capabilities plus NVA. And there is no NSG support, which is also a future in pipeline. So this is one thing we have to keep in mind when we go for hub and spoke. Other than this, I think this is a bit of a higher latency compared to the previous two scenarios, that is peering, direct peering, and co-location of the application subnet and ODA. The next slide, please. Yeah. Next one is we have discussed so far of the hub and spoke. Similarly, it is more of an similarly the other way to look at is vWAN. This is another network options. We can build this. The peering, everything is same as compared to earlier, but the vWAN with the vWAN we set the firewall, and here we literally do not need an NVA because this is an vWAN scenarios where the traffic control majorly happens on the vWAN hub, and routing messages is managed by vWAN hub itself. And latency standpoint of view, this is very closer to the hub and spoke we have decided, or slightly better than hub and spoke using a vWAN. But all that depends upon the zone, the region, and there are a lot of other aspects we need to take into consideration. Next slide, please. Yeah. The another scenario is, I think your applications resides in one region and your ODA in another region. I think Microsoft preferred solution for this kind of an connectivity is through vWAN. Again, the vWAN hub between these two regions, then the peering one side applications to the regional vWAN, and other side a ODA to a regional vWAN, and then it is kind of an peering cross-regional vWAN as a peering. Then I think that you have the connectivity in place using this topology, the firewall configuration, everything on a vWAN hub. But I think that the latency is between an inter-region. I think this is often higher latency considered to the other same region hub and spoke or a vWAN topology we have discussed so far. Next slide, please. Yeah. The last one, the most important one is ODA on Azure. How do we connect the ODA to an on-premise? It could be an application or other scenario. Maybe you have a database already on-premise. You want to move the data to ODA, data migration. In these scenarios, it is how do we connect? I think this is also typically an hub and spoke model that is well applied patterns connecting on-premise to a cloud. We have specifically for Azure, we have express route. What do you mean by express route is one is basic network connectivity. Other capability required is how do you provide the bandwidth between on-premise and the Azure cloud in the region. The express route provides kind of a dedicated connectivity between the on-premise and a cloud where you can even define what is the bandwidth requirements. There are different bandwidth offerings. Express route is a service. I think this is the most common network scenarios we thought we would discuss with you all today in this session. Any other slide, Thomas?
I think this is the last slide on the topologies, so we can.
Yeah.
I think we can go over to Q&A.
Yeah.
Thank you, Kishore. Thank you, Thomas. Ready? Lots of good information here. And I'll kick off a larger poll. Please, for our audience, take a moment to answer that. And one of the questions is to post all the links in the Q&A box. I just posted that in a previous question, so you should find all the links there. And we have a question here. What's latency measurements from on-prem? EMEA, you want to answer this one?
Yeah, sorry, I was just typing
Yeah.
typing an answer to that question, as you probably saw. So yeah, so the latency measurement to on-prem will of course completely depend on the connection that you have between Azure and your on-premises data center. So it's really difficult or virtually impossible to give a single answer for that, because it will depend on the distance and the line and all of that sort of stuff that you have between your on-premises data center and your Azure region.
So latency-wise, it's definitely going to be longer than if you are doing across the zone. Across the Azure zones, yeah.
Yep.
Next question, how about migrate workload from OCI to Azure? What topology is the best? Ricardo?
Hi, yes. The good thing about this service is that it provides a connectivity from Azure, but it also creates a shadow configuration in OCI. So this simplifies a lot the migration if you want to migrate services that are either in OCI or that are connected to OCI. So and then you can use any of the tools or most of the tools that we have. We commonly support recommend setDM, but yeah, but it's something that needs to be analyzed carefully. Okay, but from a network architecture point of view, the migration can be done either from Azure, from on-prem to the endpoint that is on the Azure side, or from OCI or on-prem to the endpoint that is on OCI.
Thank you, Ricardo. Next question. If setting up cross-region data guard, does the traffic stay on the Azure backbone, or does it go through OCI instead? EJS?
Thanks, Ray. I think this is an interesting question, guys. So yes, the data guard traffic, when you configure data guard through OCI as an automated way, it stays over the OCI network backbone. However, if you're doing manual data guard, you can choose between the two. But I think from the service perspective, out of box with all the automation, it's just all over the OCI backbone.
Thank you, EJS. So my understanding is putting your application and together with your database in the same subnet, and they use dedicated subnet to access database. And also the VNet peering, the two topology we recommended. And how is there a limit? How many VNet I can peering with the database VNet?
Yeah. So the number of peerings, direct peering you can do between VNets is 500 is the limit. However, 500 is a high number, right? So is it manageable to have 500 directly peered VNets? That's a question you have to ask. But that's the upper limit within Azure.
Thank you. But the next question, how about the migrate work? Oh, we already answered this one. And so Thomas, if I have some applications that requires low latency, and I have to do dedicated subnet or VNet peering, but I have other applications that's probably analytics. It's not so latency sensitive. Can I mix and match these topologies in my network solution?
Yes, of course. Yes, of course. So both direct peering from certain VNets, and then for lower latency, and for the latency sensitive applications, can be mixed with a hub and spoke topology for other applications to first pass through the hub VNet and then go to the database VNet. So there is a possibility to mix these topologies.
Thank you. And any questions from our audience? Please put in the Q&A box. And EJS and Julian, any experience you want to share? That's onboarding.
I think I was just going to highlight the fact you could have mixed kind of topologies, and the key really is to understand application requirement, and as Thomas said, then once you know if you've got very chatty applications, then you can choose the right topology. From the service perspective, it's more seen as what is your kind of patterns already in place in Azure. If you're using hub and spoke, or if you're using virtual WAN, or if you're just using direct pairing, all of those are supported. And from deployment consideration perspective, just knowing that this is a delegated subnet which we create is another important factor to consider when you're actually designing the solution with OD at Azure.
Exactly, and as it was mentioned, remember that with an EXA infrastructure, you can deploy separate VM cluster, each of them in a different VNet. So you can combine all the topology. You can do VNet peering. You can do local VNet for another one and get access from on-prem with your hub and spoke. So you can it's really flexible, and you can rely on Azure topology for your network.
Thank you. And to remind the audience, so the V1 option is only used for cross-region networks, right?
Could be used for hub and spoke too, right? So it's
okay.
yes. So one of the topologies that we showed is that instead of using a hub VNet with a routing device, an NVA or firewall, instead of that you can use the V1, the virtual one, to connect a spoke to the database VNet through a V1, right? So it's an alternative, and it's the benefit of that is that you don't need that local NVA in the database VNet.
Okay, so that is Microsoft recommended solution for hub and spoke.
Currently, this and Kishore, please correct me if I'm wrong, but currently this is indeed the recommended for hub and spoke.
Yes, Thomas, some scenarios, the customers, we have seen customers, they have already a vWAN between on-premise application. In that case, in that scenario as well, we just peer ODA VNet into an vWAN hub, and then, business as usual, the connectivity as usual. It depends, like, what is the network topology implementation customers or the solutions. While defining the solutions, we choose whether it's a vWAN or traditional, the hub and spoke.
Okay, so the difference is really if you do the traditional, you manage yourself, and then you need that local NVA in the database VNet. So there's an extra hub.
You are right.
Thank you. All right, we're at the end of our session, so I'll wrap up. And we really appreciate your time, and a special thank you to Kishore, Thomas, Emil, Rahul, Ricardo, and Ijaz and Julian for this office hour. And we'll have an exit poll. So for our audience, please take a moment to answer that before you exit. And thank you so much for your time. We'll see you next time. See you next month. Bye.
Bye.